Hi, thanks for viewing this presentation. I am Hua Leung Sin of the Chinese University of Hong Kong. The topic of this presentation is relationship between transportation networks and urban development in Hong Kong using space syntax. The objectives of this paper are to examine the application of the theory of space syntax in Hong Kong and to explore its implication in sustainable transportation development. First of all, I would like to briefly talk about the space syntax theory. The theory of space syntax suggests that topological distance rather than physical metric distance should be considered in the level of accessibility of space. The theory of space syntax concerns the relations between different spaces and how these spaces are connected in the network. As a theory of space syntax concerns connectivity and requires a connectivity graph for analysis, translating our surrounding space into a node-length graph is crucial. For example, Figure 1 shows a floor plan of 3 rooms and a corridor. Thus, they can be considered to be a node in the graph as shown in the figure. The door connects the rooms to the corridor and therefore they can be seen as a link between 2 nodes in the graph. Figure 2a shows a primal problem where the focus is on the nodes, which refer to the street junctions while the links refer to the streets in this occasion. The basic unit of primal problem is node. The other representation is dual problem, where relations between the links are traced. Relationships between trees are identified and the nodes become the connection points. In dual problem, the basic unit is link. In a sense, the original node-link graph of Figure 2a can be transformed into Figure 2b. Links become nodes and nodes become the links. This representation is relatively abstract, yet it considers street segments and objects, and the junctions are relationship between these objects. Many different researchers adopted the theory to study the structure of streets or a road network and the connectivity of different places in the network, such as downtown Stockholm and the City of London. This paper attempts to adopt such a theory to explore the relationship between urban development and connectivity in terms of land use change from the year 1988 to 2007 in Hong Kong. Here are the maps of the rail and highway networks of Hong Kong. And here are the figures showing the connectivity graph of rail and highway networks. And this is the figure showing the mean depth of all rail stations of the rail network in the year 2007. Space syntax approach is adopted in the study of this paper. A set of space syntax parameters of connectivity and integration of both rail and highway network for Hong Kong during the study period will be obtained following these equations using the primal problem approach, since both networks aim to connect one point to another point and our behavior occurred around these points. Here are the land use information of year 1988 and 2007. 10 categories of land uses are examined in the analysis, including private, public, rural and temporary residential, commercial, industrial, institutional, open space, agricultural and fish pond land uses. The smallest spatial units for analysis is the Territory Planning Unit, TPU, and the boundary following the definition of the 2001 census. Principal Component Analysis, PCA, is a statistical data reduction method to reduce a set of variables into a smaller number of variables, and it is adopted for the analysis of the land use change data to extract significant components for interpretation. In the results of PCA, 5 components with eigenvalue higher than 1 are extracted, where 65.5% of the variance is accounted for by these components. The component matrix of the 5 components shows the loadings of these components bear towards different categories of land use. Only loadings higher or lower than positive 0.5 or negative 0.5 are highlighted for interpretation. According to the loadings table, the 5 new extracted components can be interpreted as 5 new explanatory variables. Component 1 through 5 can be interpreted to be the change of rural area, change of urban area, change of public and temporary residentials, change of institutional and open space, and change of fish pond, respectively. Stepwise linear regression is applied to construct a model attempting to examine components 1 and 2, while these 2 types of changes reflect the major elements of urban development. 2 regression models are built with these 2 components being the dependent variables, and all the spatial test parameters and the land use data of 1988 are imported to the model as independent variables. Here is a regression result of the change of rural area. Only 3 parameters are considered significant, including industrial and private residential land use of 1988 and the mean depth of highway network of 1988. The results indicate a rural-urban conversion process. The areas where industrial and rural residential land uses increase are also the areas where agricultural land use decrease. And the depth of the year 1988 highway network is found significant in such a process. Here is a regression result of the change of urban area. Again, only 3 parameters are considered being significant. They are commercial and private residential land use of 1988 and the change of connectivity value of rail network. The intensity of commercial land use is related to the increase of railway connectivity value. And the increase of such value means a new interchange rail station connected to a new rail line or the area where new stations are completed. And the new interchange rail stations are often associated with new residential development along with big shopping malls, which explain the results. The result also signifies that the areas where the commercial land use intensity increased between the year 1988 and 2007 are probably located in the areas where the intensity of private residential is high. This particularly points to the redevelopment projects in the inner city area and the new big shopping malls built near the residential area. To sum up, the results of the analysis shows some pattern of the relationship between transportation and urban development from the year 1988 to 2007. Here are some brief conclusions of such pattern. First, rural-urban conversion in the rural part of the city is more related to the development of the highway system. Second, the urban development in the urban area shows a different track with the improvement of connectivity contributed by the rail development. Then we will proceed to the next part of this paper about sustainable transportation. In the figure, you can see the cycle of the relationship between urban development and transportation. The transportation infrastructure improves the network and accessibility of different places, which alter the travel pattern of the city. And then it can lead to the change of land use, which therefore creates further travel demand and places demand for improvement in the infrastructure. As Newman and Kenworthy mentioned, transportation is always the key to city development, which allows development to be located in the narrow transport corridors. In Hong Kong, there are many new towns. The original plan of the new town's development in Hong Kong aimed to provide employment opportunities for people in the new towns. This is similar to some of the Western cities which employment centers are planned in the suburban area as non-urban working locations in order to minimize the distance and volume of trip generated. This is the reason why there are industrial complexes in some of the early new towns in Hong Kong. However, the situation gradually changed along with the decline of secondary industry and the rise of tertiary industry, particularly financial industry, in the 1990s of Hong Kong. The availability of work came back to the high-density financial district, which is located in the center of urban core. According to 2006 by census, only about 19% of the workforce lives in the urban core. However, around 41% of work is located in these districts. The new towns in Hong Kong are basically residential in nature now, and this huge number of population has to travel from home to work every day with different means of transportation. Under these circumstances, railway is the best option for its massive passenger capacity and low emission rates per passenger than all other transportation systems running on road. And the results of the analysis of this paper also indicates that in recent years, private residential development is closely related to the rail development. This is the direction of development of Hong Kong is moving towards, where railway serves to be the backbone of the city. Although the bus system currently is the major means of transportation for its capacity and huge network coverage, it is not as sustainable as a railway in environmental perspective. Therefore, long-distance and cross-district bus lines should be limited, and the road of buses should be limited in local connection to the railway stations. And not surprisingly, all these strategies will result in creating high-density development surrounding the rail station. However, the analysis also points out that the rural-urban conversion process in the rural part of the city depends on highways, which may be an issue needed to be concerned by the government for better planning. Spacing tests concern connectivity of a network, and there are a number of previous studies which have found that the theory provides a possible way to study how people perceive space and how space structure alters our behavior. The analysis of this paper attempts to apply such approach in analyzing the relationship between transportation network and the urban development process. As a result of the analysis of this paper show that the change of urban land use is related to the structure of rail network. It paved the way for future researches regarding how connectivity shaped by such structure affects the urban development, especially when such network structure does not directly relate to the physical distance, as the theory of spacing has proposed. In other words, the structure of a transportation network may alter the definition of distance and stimulate the urbanization process in some distant places with rail network provided. And at the same time, it may improve the percentage of people using such energy-efficient means of transportation. We are living in a network, and a network structure does have impacts upon our behavior. This is the end of our presentation, and thank you very much.